Welcome back. In this video, we are diving into the world of collections in C Sharp, focusing on the uh, simplest type arrays. Arrays are like toolboxes for your game's data, holding a set of values neatly together. So let's discuss how they work and how you can use them in your games. So, what are arrays? Imagine you have a shelf with boxes, and each box can hold an item. In programming, this shelf is called an array, and the boxes are called elements. Arrays are great for storing a list of items like high scores or inventory items in a game, where each item has its own spot on the shelf. Uh, so some of the key points about arrays are all the elements or items in an array need to be of the same type, like all numbers or all integers. And once you set up your shelf with a certain number of boxes, you can't add more boxes or take any away. The size of an array is set when you create it and can't be changed. And also, if you don't put anything in the boxes right away, they don't stay empty. Number boxes get a zero, and other types of boxes are considered empty or null. So let's see how we can create an array. Yeah. So creating an array in C Sharp involves several steps, but it's not complicated. This is the initialization of array, and let's say we are keeping track of top three scores in a game. We can store these scores in an array like this, and this means that we have an array named two player scores ready to hold three scores. Since we didn't specify the what the course is since we didn't specify the what the scores are yet, the default each score is 0. So you can fill your arrays with values right from the start using two methods, the long method and the short method. Both methods are correct, but the short method is like a shortcut that saves you a bit of typing. And each box on your shelf or element in your array has a number starting with 0. So to get the first score, you look in the box 0, and so this gets the first score. And why use arrays? So why use arrays? Arrays are fast and straightforward, making them perfect for data that doesn't change size, like a fixed list of levels in a game or a set of number of player lives. So arrays and C Sharp are fundamental tool for organizing data effectively, and they keep your game's information tidy and accessible, just like box on a shelf. So experiment with creating and using arrays in your projects, and you'll see just how handy they can be. And so now we are going to unlock the secrets of arrays, array indexing, and subscripts, which are important tools for working with arrays in C Sharp. Think of an array as a row of mailboxes, each with its own unique number. Indexing helps us find and use the contents of each mailbox effectively. So, what is array indexing? So, imagine you have a huge apartment building, and each apartment has a number. And in programming world, these apartments start counting from 0, not 1. So this is what we call zero indexed. So the first apartment is apartment 0, and the next is the apartment 1, and so on. So to check the mails in one of these apartments, you need to know its apartment number. In C Sharp, we use the subscript operator, and to do this. So here's how it works. Basically, to get a mail, to get the mail from apartment one, we'd write top score is equal to top player score 1, so which gets the apartment 1 value. So this tells C Sharp to look into the second mailbox, and gives us what's inside. So What if we get new mail or need to update what's in the in a mailbox? Easy, we use the apartment number and put the new mail in. So just like this. So this is how you do it. So here's where we need to be careful. Our apartment building only has three apartments, 0, 1, and 2. So if we try to check the apartment mail in apartment 3 or beyond, we'll run into trouble because those apartments don't exist. In C sharp, this mistake throws a index out of range exception, telling us we are gone out of bounds. So to avoid peeking into non-existent apartments and causing errors, we always make sure that the apartment number, which is index, is within the range of our array. So if our building has three apartments, we stick to indexes 0, 1, and 2. So uh, understanding indexing and subscripts is like having a key to every apartment in the building. So it lets us access and update information in our arrays effectively, making our code smarter and our games more dynamic. While arrays are fantastic for fixed number of items, sometimes we need a more flexible setup. This is where lists come in, offering the ability to add or remove mailboxes as needed. Uh, so the next topic is lists. We are stepping into the flexible world of lists in C sharp. So lists are magical backpacks in your programming, in game programming, allowing you to store and uh, different types of items of allowing you to store items of the same type and manage them with ease. So let's explore how lists work and how they can be used to create dynamic games. So what are lists? Imagine preparing for a quest and have a backpack. You might start your journey with just few items, but as you progress, you find more treasures to add, or maybe you use some portions and need to remove them. Lists in C sharp are similar to this backpack. They hold items which are elements of the same type and let you add or remove items dynamically as you need as your needs change. So creating a list involves a few simple steps. So this is the basic syntax for the list. So let's say you're assembling a party for a grand quest. You want to keep track of your party members. So this is how it looks. The code looks like this. So we start by creating a new list name called quest party members. This list is set to hold strings, each representing a party member's name, and we initialize our lists. We initialize our list with names of three characters. Unlike arrays, we don't need to decide the size of our list upfront. We can add as many members as we need along the way. And to see how many adventures have joined our quest, we use the quest party members dot count. So this tells how many items are in our list. In this case, the log will show party members 3. So lists are incredibly versatile. They automatically adjust their size as you add or remove items or elements, making them perfect for when you don't know how many items you'll end up needing. While they might be a bit slower than arrays for certain operations, their flexibility often makes them the best choice for game development. So I encourage you to play with this code, try adding more party members to the quest party members, or use the dot remove method to see what happens when a character leaves the party. So this hands-on practice is a key to understanding how lists can dynamically manage data in your games. So let's go back. So lists in C Sharp are a powerful tool for managing collections of data from party members in an RPG to inventory items in an adventure game. As you become more familiar with lists, you'll find they become an indispensable part of your game development skill set. So now we are going to dive deeper into lists in C sharp, and discover how to manipulate them with some common methods. Think of lists as dynamic teams in our role-playing game, when where we can add, insert, and remove team members as our quest evolves. So let's get into how we can manage our quest party members more effectively. So first up, we find a new ally like called Craven the Necromancer. We want to add them to our party. C sharp makes this easier with the dot add method, and so basically this line tells our program, hey, let's welcome the Craven end our to the end of our party list. Now our team grows from 3 to 4 members, and but what if we want to we what if we meet Tanis the thief and decide they should join right after Grim the barbarian, and so we use the insert method for this, and this line of code uh, inserts into the second position. Remember, we are starting from zero, moving everyone else down the list. Our party order changes, but no one gets left behind. And removing a member. So these both sometimes a member leaves our quest, we can remove them by name or by their position in the team. So this is how we can remove members. So both lines are effectively remove the Grim the barbarian from our list, whether he is taken from another quest or retired. He's no longer in our party. So after adding the caravan and after adding the Carven and Tanis, and saying farewell to Grim, our party looks like this. So the beauty of lists is in C sharp is their flexibility. With these methods, we can dynamically adjust our party based on the needs of our quest. Adding, inserting, and removing elements on the fly allows our game to respond to player decisions and game events in real time. So lists offer even more capabilities like checking for specific values, finding and sorting members, and dealing with group of items. These tools are important for managing game data effectively. So we have seen how to make our quest party dynamic and responsive using the list class in C sharp. As you practice with these methods, think of how you can apply them to manage a game inventory, dialogue options, or even NV swarms. So the possibilities are endless. And the next topic is dictionaries. We are diving into the world of dictionaries in C sharp. Imagine you're in a you're in a library. Each book has its unique code, and that leads you directly to it. Dictionaries work similarly in programming, storing information as unique key value pairs, making it super easy to find and manage data. So let's understand how dictionaries can be a game changer for storing complex information like inventory items in our games. So what are dictionaries? Dictionaries are a bit like magical inventory bag in an RPG. Each item in your bag has a unique tag or label, so you can quickly grab it without wasting time. So in programming terms, the key is what we use to look up the value. So creating a dictionary involves what type of keys and values it will hold. So this is a uh, simple formula. So let's set up a inventory of our character with items and their quantities. Uh, so we start by making a new inventory called item inventory, and our keys are strings, the names of the items, and our values are integers. How many of each item we have, and so we immediately fill our inventory with items, potions, antidote, aspirin, so along with how many of each we have, and using the uh, item inventory dot count, we can see how many different types of items are in our inventory. In our case, we have three types of items. So dictionaries shine when you need to access or update information quickly based on the unique identifier, like item names in an inventory. They are specifically handy when the data is complex, or when you need a quick way to look up values without searching through a whole list. And you can add, remove, and update items. If our hero finds more potions, we can easily add them to our inventory. If you use up all of one item, we can remove it from our inventory. And after a battle, you might need to update how many potions we have left. So that's when you use update. So dictionaries in C sharp are powerful tool for managing data in in your games. They let you keep track of complex information like inventory system effectively and intuitively. Experiment with creating and manipulating your own dictionaries. You'll see how they can help organize and enhance your game's data management. So now we are going to understand the art of managing dictionaries in C sharp. Imagine dictionaries as a treasure maps where each landmark leads you to a specific treasure. So let's discuss how to add, update, and remove these treasures in to keep our game inventory up to date. So first off, finding how many portions we have is as simple as looking up a landmark on your on our map. So this line of code checks our map for the portion landmark and tells us we have 5 portions. Easy, right? But what if we find more portions? We update our map just as easily. So by using this line code, so now our map shows the portion leads to a treasure of 10 portions. And you can also add new treasures. So discovering new items is a part of any adventure. Let's say we find some throwing knives. We can add them to our map in 2 ways using the add method. So this is like drawing a new landmark on our map when it's when with its treasure. And the other way is using the subscript operator. If we use this method with a new landmark, it gets added automatically. And so our map is magical, but we must be careful. Trying access to a landmark that doesn't exist might accidentally create a new one. To avoid this, we check if the landmark exists before updating it. So by using this code, we can this way you can only update the aspirin treasure if it's already in our map. So sometimes you need to remove landmarks on from your map. uh, Maybe because a portion is used up or an item is lost. We can do this by using this. So now the antidote landmark is no longer in our map. So dictionaries are in C sharp are powerful tools for managing game data. They let us quickly access, update, and manage our game's inventory with precision. By learning how to use dictionaries effectively, you can create more dynamic and interactive games. So uh, yeah, we discussed about all about dictionaries. We learned how to add, update, and safely manage our game treasures. So experiment with these techniques in your projects and see how they can help organize and enhance your game data management. So now we'll discuss about iteration statements, also known as loops. Imagine you're on a quest and need to check every room in a castle or every item in your backpack. Loops helps us do just that in programming, allowing us to go through each item in a collection like a list of quest party members one by one. So let's discuss how we can use loops to make our code smarter and our games more interactive. So what are for loops? So think of for loops as a checklist. Before you start your day, you decide on the number of tasks you plan to complete. So as you go through your day, you check off each task one by one until you're done. In programming, a for loop works similarly, repeating a block of code a specific number of times. So this is the basic syntax, basic structure of the for loop. We have a initializer. This is where we set up a counter, usually named as I. starting at 0. And the condition, this tells the loop how long to keep going. For example, as long as I is less than the number of items. So, and iterator, this is where we update the counter, like I plus plus, usually by adding, one each time the loop runs. So this is a practical example. Let's say we have a list of our quest party members, and we use for loops to greet each member. And so we start our counter I is equal to 0, and I is at 0 because that's where list starts counting. And our condition checks I less than the number of party members, ensuring we don't go looking for rooms in castle that doesn't exist. After each loop uh, we add 1 to I, so we can greet the next member in line. So inside the loop we have a special shout out for Merlin, showing how we can execute a specific code for certain conditions. So for loops are incredibly useful for handling tasks that involves going through lists or arrays. They are clear, concise, and keep our code efficient. Plus, they can be customized for more complex conditions, making them important tools in your programming skill set. And so we learn about for loops and how they help us iterate over collections like a list of quest party members. Experiment with for loops in your code, try out different conditions and actions. Remember, programming is like a puzzle, and loops are key pieces in solving it. So the next topic is for each loops, where these loops are like your game's way of saying I want to check on every member of my team one by one without missing anyone. Whether you're looping through a list of party members or checking every item in an inventory, for each loops makes it simple. So let's see how they work and apply them in our game scenarios. So what is for each loop? Imagine you're sitting at a campfire with your quest party, and you want to pass around a health potion to each member. You wouldn't count them first or worry about their order. You'd simply hand the potion to each person until everyone has had a turn. So that's what for each loop does in programming. So this is a general structure for each loop. So uh, the element type, this is the type of items in your collections, like for example string of names. So and the variable name, this is a new variable that represents the current item in the loop. And collection is, this is the collection you're looping through, like for example list of names. And so let's take the example called party roll call. So in this example, we are for each member of quest party members, we create a temporary variable called party member to hold their name, and then log a roll call response. So dictionaries store information as a key value pairs, like a item name or its quantity. So to loop through a dictionary, we use a special type called uh, key value pair. So let's see another example. So let's see another example. So here, item dot key. So this represents the item's name, and item dot value is its quantity. We go through each item in the item inventory, and logging its name and how many we have. So let's add a twist to the let's add a twist. Suppose your character has 4 gold coins, and you want to check which items they can afford. So uh, this loop checks each item's price against your gold coins. If the item cost, item dot value is less than or equal to your coins, it logs you can afford it. So For each loop are perfect when you need to work with every item in a collection, but don't need to worry about their order or position. They keep your code clean and readable, especially when dealing with complex collections like dictionaries. So, so we have seen how for each loops simplify iteration over collections, making tasks like inventory checks a breeze. So experiment with these loops in your projects and watch how they can manage collections uh, more intuitive and fun. So the last topic for this video is while loops. So imagine you're playing a video game and you have a few lives. As long as you have at least one life, you can keep playing. This is exactly how while loops work in programming. They keep running a block of code as long as a certain condition is true. So let's break this down with an easy to understand example. Before that, let's understand what while loops are actually mean. So what are while loops? Think of while loops as a video game level that you can keep playing as long as you don't run out of lives. In programming, the lives are just a condition that we check before running our code block again. So this is the basic structure of while loops. So this is the initializer. So we start by setting a variable called player value lives is equal to 3, and the condition. So the loop checks if the loop checks if player lives are greater than 0. If it is, it runs the block inside the loop, and inside the loop we decrement the player lives to by 1 each time the code runs. So this eventually makes our condition false, make it when lives run out, stopping the loop. So let's see a real-time example. So in this code, each time the loop runs, it logs still alive. When player lives drop to 0, the player stops and prints this message. So a loop becomes infinite if its condition never becomes false. For example, if you forgot to decrement the player lives, the condition player lives greater than 0 would always be true. Our program would keep running the loop non-stop. This can breeze or crash your game. So to prevent infinite loops, always make sure your loops condition will eventually become false. Double check that you are correctly updating any variables involved in your loops condition. So while loops are powerful tool in your programming, especially for repeating tasks as long as the condition is met. They are like saying, as long as I have reasons to keep going, I won't stop. So just remember to use them wisely to avoid getting stuck in an infinite loop. So uh, we have covered a lot of ground, from making decisions in in our code to with if else statements and switch statements to organize our so we used with the if else statements and a switch statement to organize our games data using arrays, lists, and dictionaries. Let's take a moment to revise how these tools empower us to create more dynamic and interactive games. So we have learned how to direct the flow of our program with the if else and switch statements, allowing us to respond to different game states and player actions. And by using arrays and lists, we have seen how to handle collections of similar items like inventory systems or enemy types. Uh, Dictionaries have shown us a powerful way to store and access data through unique keys, perfect for item properties or player stats. And we also explored about how to efficiently cycle through our collections to perform actions on each item, whether it's updating scores, checking inventory, or processing game events, all while keeping an eye out to prevent those tricky infinite loops. So if you're feeling a bit of overwhelmed, that's completely normal. Programming is as much as about building mental strength as it is about learning syntax and logic. Each concept we covered is a skill in your skill set. ready to be applied in your own games projects. So as we move forward, we are going to dive deeper into the C# programming with classes, structs, and the principles of object oriented programming. So these concepts will take what we have learned so far and apply them to creating and managing objects in Unity, giving us even more control and flexibility in our game development process. So the best way to solidify your understanding is by applying what you have learned in small projects or experiments. So try creating simple programs that use these concepts, like text-based adventure game or an inventory of an hypothetical RPG. Each line of code you write brings one step closer to bringing your game visions to life. So remember, every great game developer started somewhere. The skills you have, the skills you are building now are the foundations for your future success. So stay curious and keep experimenting. That's all part of the learning process. So yeah, thank you for watching, and remember to subscribe and like. Yeah, see you soon.